Every millisecond your app spends fetching data is a millisecond your user spends thinking about closing the tab. Picture your web app as a restaurant. Every time someone orders a fruit salad, you hop in the car, drive 20 miles to the farm, pick the fruit, and drive back. That's your database call. It's slow. Caching? That's stocking the fridge, so the fruit is ready to go. And the best part? You can cache almost anything. Welcome to Caching 101 in ASP.NET Core. Our first weapon is IMemoryCache. It's in server RAM, blazing fast. Add this weapon in program.cs. To use it, inject IMemoryCache. Then try to get your data by its cache key. If it's missing, fetch it from the database and set it in the cache. Next time a request comes in, data is served instantly without even touching the database. It's speedy and reduced database calls. But beware, RAM is fast yet fickle. Restart your app and the cache vanishes. Plus, RAM is limited and not just for your cache, so set boundaries before your cache eats the whole kitchen. Speaking of being efficient with your resources, I found my own internal cache for my creator workflow lately. I know a lot of you are making demo videos for your own apps, your SaaS, or your brand, so here's something you need to see. These are the captions generated in CapCut, and these are generated in CaptionBolt. See the difference? I have high standards for my video captions, and maybe you do too. But CapCut just doesn't work for me out of the box. It takes too much time to tweak manually, like a slow database call. But with CaptionBolt, all these criteria are met instantly. Just upload your video. Let it auto-transcribe. Then pick a caption style. There are 300 options here. Adjust position. That's it. Click export and download your video. You're running 2 tasks. Honestly, looking at the result, it feels like a professional perfectionist editor did it for me. I was quite surprised that little details like the pauses, the timing for each pop, the clean design, and the smooth animations are handled so perfectly. Need high-quality captions for your coding videos, app demos, or SaaS marketing? Check the link below and use code ORTHEME50 for 50% off. Now, here are the things we need to set when using caching. First boundary, set a size limit. It's like telling your cache, no more than 100 items, buddy. Next, assign each cache item a size of 1, because without this, the global size limit will throw an invalid operation exception. The limit doesn't care about units. It just counts items. But if you want it to feel like real memory, switch to the byte method. Here, we're setting a max of 100 megabytes. Then, for each cache entry, calculate the actual byte size of the object. Second boundary, expirations. We have sliding expiration, like an inactivity timer. If nobody touches the cache for 30 seconds, it's gone. But if it gets accessed, the 30-second timer resets. Then there's absolute expiration, like the cache saying, I don't care if you touch me or not. After 10 minutes, I'm out. And yes, these two can team up for maximum effect. Third boundary, priority. Each cache entry can be assigned a rank, low, normal, high, or never remove. When RAM is full, IMemoryCache triggers a process called eviction, sweeping items out to make room. First, expired entries are cleared. Then, items with the lowest priority are removed. Now, imagine we cache all FAQs for 12 hours. Just 10 minutes in, the admin hero swoops in and says, "What? Typo? Let me fix this." Yes, the typo is corrected, but users will still see that mistake for another 11 hours, 50 minutes. That's why we need cache invalidation. When the admin updates or deletes, remove the old cache so it refreshes and everyone sees the updated data. IMemoryCache is fantastic until you scale across multiple servers. Imagine your app gets so popular that you need to scale the server. You can scale up, just add more RAM, or scale out by spinning up 5 budget servers all running the same web app. If you choose to scale out, a load balancer sits in front, directing traffic. User A goes to server 1. User B goes to server 2. Here's the catch. User A adds an item to their cart on server 1, and it's cached there. Then they click checkout. but the load balancer sends them to server 2. Oops, server 2 has no idea about the cache. The solution? Move the cache outside your servers. So, welcome to level 2, distributed caching. Here comes our hero, Redis. Think of Redis as a giant community fridge parked outside, accessible to all branches. Redis stands for Remote Dictionary Server. It's a super fast in-memory data store. We store the cache inside, and all servers share it. We need to install this NuGet package. In appsettings.json, add the Redis connection string. But where to get the connection string? For local testing, open up Docker and run Redis, like this. Then use localhost 6379 in appsettings.json. For production, buy the Azure cache for Redis. Yes, we'll need to pay extra costs to use Redis. Create a new instance in Azure and copy the connection string. In program.cs, introduce Redis to your app. Inject iDistributed cache. Now your app can grab the cache from Redis. If the cache is found, Redis will return the cache data as a JSON string. You need to deserialize it into your C# list. If not found, fetch from the database, serialize to JSON, and don't forget expiration rules. Sliding expiration and absolute expiration, then save to Redis. Now one of the benefits of using distributed caching, since the fridge is outside. Unlike IMemoryCache, the cache will remain in Redis even after restarting the app. For cache invalidation, simply remove the cache entry like this. However, there's something important to keep in mind when working with Redis. First, serialization. Redis requires serialization and deserialization. If you try to cache a massive object, the CPU might spend more time translating it than just fetching from the database. So, keep cached objects lean, paginate lists instead of caching the entire table. Second, location. If your Redis is in East US and your web app is in West US, every request is like a cross-country road trip, adding extra time. Always keep Redis in the same region as your app. Third, versioning. Say you cached user 1 with a username and phone number. Later, you change username to email. When retrieving the user 1 cache, it's found, but deserialization fails. To fix this, use version prefix. For example, the old cache key might have prefix v1. When you change the data structure, switch to v2. This way, if the v2 cache key isn't found, it will be rebuilt, while the old v1 cache key will quietly expire when its time is up. Some teams choose to simply flush the entire Redis cache during deployment, but it will have risk of causing cache stampede. Once Redis is flushed, all cache data is gone, and your database suddenly gets hit by a large number of requests at the same time. This spike can overwhelm your system and hurt performance. So versioning is safer. It lets the cache repopulate gradually instead of causing a traffic jam. Plus, most of the time, you won't be changing the whole data structure, just a small part of it. So, there's usually no need to flush the whole Redis cache. Ever wondered if in-memory caching and distributed caching could team up like a superhero duo? Oh yes! Welcome to Level 3. Hybrid Cache, only available in .NET 9. Step 1. Install this NuGet package. Summon add hybrid cache in program.cs. Step 3. Inject hybrid cache into your service and unleash get or create async. This little spell first checks the local memory, then checks Redis. And if both fail, it bravely ventures into the database and saves the cache in both. Want Redis to go first? Sorry, we always go for the fastest first, so by default it will check local memory first. But if you still want to use Redis only in hybrid cache, then use hybrid cache entry flags.disable local cache. What about expiration? Set it globally like this, or override per call. You can also tweak maximum size for cache entry and maximum characters for the cache key. How to do cache invalidation in hybrid cache. Use remove async or remove by tag async if you set some tags to a cache. And now the cache will be removed from both local memory and Redis. Here's the real magic of hybrid cache. It automatically fixes the cache stampede. If 1,000 users request for the same expired key at once, Hybrid Cache politely locks the door. First request ventures to the database to refresh the cache, while the other 999 just relax and wait for the hero's return. Now, let's see our level 4, cache key best practices. Every cache has a key, but without delimiter, your keys might turn into this. Was it customer 42 and order 123, or customer 421 and order 23? Yes, use delimiter to avoid ambiguity. Also, never let user input sneak into your cache keys, else you'll get security nightmares or random meaningless keys. Just now we explored the data caching, but we can actually cache the entire page. This brings us to level 5, response caching. It's like the web page has already been captured as a snapshot and shown to the user instantly. This is the fastest type of cache, since the request never even reaches your server, though you have zero control over it. Here's how it works. In program.cs, add response caching and use response caching. If your program.cs includes useCores, make sure to call after useCores. Then, add the response cache attribute to the method you want to cache. You can set the cache duration in seconds and the location. Duration translates to max age in the cache control HTTP header. Think of max age like a best before date on milk. Max age equals 3600, means good for 1 hour. Here's how the response cache attribute maps to headers. When it comes to response caching, even if we set a duration, we can't fully control it since users can hard refresh their browser to clear the cache. That's where level 6, output caching, comes in, the modern replacement for response caching. Unlike response caching, which stores cache on the user's browser, CDN, or proxy, output caching stores the fully rendered HTTP response on your server. It ignores client HTTP headers, so malicious users can't slow your site by sending no cache headers. In program.cs, add output cache and use output cache. Make sure to call use output cache after use cores and use routing. To cache a method, apply the output cache attribute, set the duration, and optionally add tags. Tags allow you to invalidate cached content by injecting ioutput cache store and calling evict by tag async. Response caching and output caching typically store the entire page, but sometimes you only want to cache a small section, like a complex navigation menu or a data-heavy sidebar. So welcome to level 7, Cache Tag Helper and Distributed Cache Tag Helper. Used in MVC views or Razor pages, they wrap specific HTML blocks for caching. This cache tag uses the in-memory IMemoryCache, while the distributed cache tag uses your configured iDistributed cache, like Redis. So, if you're building a modern ASP.NET Core web app today, use Hybrid Cache to combine in-memory and distributed caching for your internal data services and database calls. Keep in-memory cache for small static lookups. Use output caching for public-facing web pages and API endpoints where you want to cache the entire page on your server. Let the client handle response caching only for static assets like images, CSS, and JavaScript files. Congrats on finishing Caching 101 in ASP.NET Core.